code is made out of only two numbers, actually. It's only made out of zeros and ones. And those zeros and ones, it looks pretty complicated, but it's actually pretty simple. You see, the one means that the computer read a signal. Something said hello, and the computer recorded that as a one. Whenever the computer records a zero, it means that the computer did not see a signal. So no signal, zero, and if there's a signal, it's a one. And the computer reads all those things, it combines them together, and it figures out how to display things like text, pictures, anything else a computer does. Now that's getting pretty high level. Let's break it down. Let's make it a little bit simpler today. For the activity that we provided for you in the box, you guys have a piece of paper that has how to translate binary code to letters. So I'm going to go ahead and show you guys on the screen. You guys have a copy of this binary code to letter sheet right here. Oh, hello. Oh, hi. Yeah. My moderator is saying that maybe I was cut off at the beginning. That's totally fine. I'd like to welcome you guys. We are here doing a live stream for our second Math in Motion box from the Michigan Science Center. This is our MiSci in a Box STEM kit. And I was just saying hello and asking everyone, tell me a little bit about themselves in the chat. So I've actually already had some friends join us, Nyla and Amar, and it looks like there's some other people in the room as well. So right now we're talking about the very first activity in your box called binary code secrets. Now, binary code secrets is on the board, on the screen right in front of you. And that's what that first piece of paper, it has a really big map of numbers on it. And those numbers are, those correspond to letters. So we're actually going to decode a special secret right now. This secret is located on the bottom of your piece of paper, and I'm actually going to show you what it looks like from my point of view. And if you would like to work alongside me, you absolutely can. We're going to decode this secret together using this binary code. So my first sequence of numbers I see is right here. Maybe I'm actually going to use a highlighter to show you guys what I'm doing. So I'm going to highlight this right here. Now I'm looking for this series of numbers in this table. So I see that that series of numbers says 0, 1, 0, 0, 1, 0, 0, 1. So I'm going to look for this one. Now I know it starts with a 0, and it looks like all of my letters also start with a 0. That's good to know. And the second letter is 1. So we are going to look down here and look, I see that beginning with letter A, it starts out with the second letter being 1. So I'm going to keep on looking down until I find a letter that matches this sequence of numbers. So I'm going to keep on looking. It looks like I've got 2 more 1s in here, 1 the last, and then 4 from the last. So I'm going to keep on looking. And then I've got it. I see it says 0, 1, 0, 0, 1, 0, 0, 1. And that corresponds to the letter I. So again, for those of you that maybe tuned in just a little bit late, we are figuring out how computers use the language of ones and zeros to decode language. So we've got the I first. Now we're going to do the second series of numbers. And I'm going to give you guys a hint here, actually, because I've had a little bit of experience working with binary code. I actually know that this series of numbers right here, this is just code for space. So it's actually right here. You can see it. It says 0, 0, 1, 0, 0, 0, 0, 0. It's a lot of zeros, right? And it matches right here. So this is 0, 0, 1. You guys can read it. So I put I space. And actually, we're going to keep on seeing that over and over again. Our next letter that we're looking for is this series right here. And I'm going to keep on going so you guys can read that letter. I'm going to start looking for it here. Now, I know that it's probably going to be a lowercase letter based on the amount of 1s I see here. So I'm going to start looking in the lowercase letter area. Does it look like an A? So I'm looking for 0, 1, 1, 0, 1, 1, 0, 0. Okay, I'm going to keep on looking. Let's see. If in the chat, if you guys want to, you can guess what it might say. And you might be able to guess it in 1 second. So I'm going to keep on looking. Keep on looking. Oh, and I think I've got it. I think it might be an L. It looks like it's the same series of letters. So I got I space L. Okay, and we're going to keep on going. I'm looking for this one now. So I've got, you know, there's a trick here too. I'm looking for 4 ones at the very end. It's a lot of ones at the end. So which ones have 4 ones? Let's see. It doesn't look like it's an uppercase O because we're missing that one right there. Going to keep on looking for 4 ones at the end. There's 3 ones. Let's see. Keep on looking. Oh, I think I've got it. 0, 1, 1, 0, and then 4 ones. And there it is. ILO. Okay, I know this is kind of tedious. Think about how slow we're going and how long it takes to figure out what these say and how computers do it so fast, right? Okay, next series of numbers is right here. There we go. Let's start looking. Let's start back at the lowercase letters. I'm looking for 3 ones at the end of the first sequence. There we go. 3 ones at the end. Let's see. We have a guess in the chat, it looks like. Nyla guesses, I love science. Oh, that is such a good guess, Nyla. I'm so excited to see if that's what it says. It definitely says ILO. Okay, let's go with Nyla's guess. Let's see if the first word is love. So if the first word is love, that means this letter would be V. Let's go for V. Oh my gosh. Nyla, I think you're onto something. That's definitely a V. Okay, let's keep on going with her guess or with their guess. Let's keep on looking. So if the next one would be an E. Let's see, is that an E? 0, 1, 1, 0, 0, 1, 0, 1. That's it. Nyla, you were onto something. Okay, so it says I love for sure. And then this we know is a space, right? There's that space. Okay, so I love something. And it's got how many letters? 1, 2, 3, 4. It's got 4 letters. I wonder what it could be. I love something with 4 letters. Let's figure out the first thing, and then maybe we'll be able to tell. Okay, let's see. 0, 1, 1, 0, 0, 0, 1, 1. Let's see. I might remember that from something else earlier. It might be, yep, it's a C. Okay, I love something that starts with a C. Interesting. I wonder if you guys have any guesses in the chat. I love something that starts with a C and has 4 letters. Okay, let's keep on going. If you have a guess in the chat, let me know. This is the one we're looking for now. 0, 1, 1, 0, 0, 0, 1, 1. Okay, we're going to start with the lowercase a. Let's see. Oh, actually, here, I'm right here. I'm right there. Oh, it looks like it might be. No? Yep, it looks like it might be a lowercase a. I love something. I love ka. Huh. Wonder what it is. Let's do this. The 3rd letter of the word right here. The 3rd letter is right there. 0, 1, 1, 1, 0, 1, 0, 0. Start with A. See if we can find it. So we've got 3 ones at the beginning of the first part. So we'll know to go to the 3 ones. Awesome. So that's pattern recognition that we're doing. So now we're looking for 0, 1, 1, 0, 1, 0, 0. So we got our 3 ones. There they are. So maybe we missed it. Oh, yep, there it is. I love cat. Huh. Let's see. Amar says I love code. That's a great guess, Amar. It's a great guess. It honestly probably would have made more sense. Let's see. We've got I love cat so far. And finally, our last letter, 0, 1, 1, 1, 0, 0, 1, 1. Let's see if we can find it. We got all those ones at the end, so we know it's over here. And let's see. Where is it? I think I found it. I love cats. Huh, because the last thing is a, let's see, what was the last thing? 001011110. I bet you I know that's, yep, that's a period to end our sentence. So our secret was I love cats. I'm wondering if my friend Anna wrote that secret because she loves cats. So that took a while. Now, that's really cool, right? That took us quite a while, but oh, look, Lily guessed it correctly. Good job, Lily. That's really awesome. Okay, we have some good guesses in the chat. Now, that took us quite a while, right? And the cool thing is, like I said, computers do it super, super quickly. In fact, they're doing it almost instantaneously. They can read that code. Okay, you guys have been so wonderful giving me awesome answers in the chat. And now I have, oh look, someone has a cat face. So now I have a question for you. I want you guys to tell me a secret in code, but because it takes so long, how about you guys just give me one word and have that one word be your favorite color? So if you guys could give me binary code with your favorite color, I'll try to guess it, okay? So what's your favorite color? Try to write it in binary code, and I will try to guess it. Let's stick to simple colors too, so I can try to guess it if I get enough clues. Okay, so we're gonna, in the chat, if you can, go ahead and put your binary code in there. And actually, while you guys are writing down your favorite color in binary code, just one word, I'm gonna do my favorite color in binary code, and I'll write it down while you guys are working. Let's see. I'm writing down, so the way I'm doing it is I wrote down my favorite color in words, and now I'm trying to match the letters to the code. And even though we just did it, I already forgot where things were. Okay. Let's see. Do we have, so I'm done. Let's see. Type in your binary code in the chat and I will try to guess it. You know what? I'm going to do my second favorite color while you guys are working, just for fun. Again, you're going to write down where you can have in your head your favorite color and write it down in English letters. And then you can pick out, you match it to the code. Let's see. I am trying to pick mine. And it takes much longer than you think, right, guys? It's wild that computers are able to read all these signals so quickly and make so many instantaneous decisions. If you think about how quickly computers show things like new text or new graphics, this is all binary code. They're all getting it from just these ones and zeros. Let's see, my last one. Okay. Yes, it's true. I wish I was as fast as a supercomputer. Okay, I don't see anything in the chat yet. Let's see if we can get any guesses or any clues in the chat. What are your favorite colors? Hopefully you choose one of the ones with a really short name for me. Okay. You know what? While you guys are still writing, I'm going to go ahead and set up my station for our next activity. Okay. Anything yet in the chat? Maybe my moderator can give me a hand. I wonder what their favorite color is. Here we go. Okay, hopefully we're finishing up some of our binary secrets. While you guys are finishing up, I'll tell you a little bit more about the activity that you have in your box. So in your box, you have this envelope, and this envelope, it has a question mark on it, and it has 5 secrets that our Michigan Science Center guests wrote us. So these are pretty long binary code secrets, but I think you guys can handle it. These are real secrets that our guests actually wrote about a year ago here at the Michigan Science. And we gave you guys 5 of them to decode using that binary code. Let's see, the table that we gave you. If you lose your binary code table, that's fine. You can Google it. It is a standard American code. You can find it on Google Images. Okay, I'm not seeing any any guesses in the chat. So maybe if you guys keep on coming up with them, if you want to give me some later, I'll try to get to it later in the show. Okay, let's go ahead and move on to our next activity. Our next activity is called straw towers. Now you can probably guess that, right? Because I just put up some straw towers on my, I just got a binary secret. I wonder what it is. Let me see really quickly. I see that it probably has 3 letters. I bet I know what it is, but let's go ahead and see if I can figure it out. So I see 0, 1, 0, 1, 0, 0, 1, 0. Okay. 0, 1, 0, 0, 0, 1, 0, 1. Interesting. That was number 2. And number 3, 0, 1, 0, 0, 0, 1, 0, 0. Let's see, it's got 3 letters. Hopefully it's an easy one. Let me see, I might have a guess. A 3-letter color. Let me see if I got it. Yep. Okay, the first letter is definitely R. I bet you the second one's an E. Let's check it out. I think that my moderator's favorite color is red. Let's check it out. Let me see. And yep, it's an E. Well, hopefully it's red. I can't think of any other colors that start with R-E. And the last one is it a D? Yep, it's a D. Perfect. Thank you, moderator. I'm so happy to know that your favorite color is red. Okay, back to business. Let's check out our straw towers. Now, you'll see on the left, we've got huge towers. You'll see the very tallest one over here is the Burj Khalifa. That's actually the tallest tower in the world. That tallest tower in the world is about 900 meters tall, over almost 3,000 feet tall. And it is in the United Arab Emirates. And you'll also see some other famous tall towers right beside it. Over here on the right, you'll see a building that you probably know pretty well. That building is our Renaissance Center. And I think when I saw all these pictures, I was wondering, how do they make the towers that tall? Because lots of things happen. What about earthquakes? What about floods? What about strong winds? So I thought it'd be fun to do a quick experiment with some straw towers that I made over here. I made these 2 straw towers using the straws that you have in your kit. So our first thing we're going to do is we're going to measure them to see how tall they are. I'm going to get out my measuring tape and we're going to measure. They're pretty similar height. So we can check it out. This measuring tape measures in inches. So let's see, it's about this tall. And that's about, it's exactly 25 inches tall. Let's check out this one. This one's just a teeny bit shorter. This one's probably more like 23 inches tall. So they're basically both the same height. Let's do a quick experiment to see what's the difference. We've got one with a square base. You can see I made it out of squares. And then we've got another that's made out of triangles. And I don't know if you guys can see this, but the triangle one is quite a bit skinnier. It's quite a bit thinner. This one, though, is like thick and stocky. So what I'm going to do is I'm going to simulate an earthquake by rubbing these 2 against the table. I'm going to do a quick table rub. 1, 2, 3. See which one falls over. Oh my gosh, and there they go. The skinny one is a little bit less stable and it fell over. Now, that's a fun little activity. But what happens in real life? Well, I asked one of my friends. My friends told me about something really cool that's in giant towers, and that is called a damper. So I actually have a picture of it right here to show you guys. Over here on our screen, there it is. So this tower that you can see right here is called Type A 101. It's actually one of the towers that we have featured in Math Alive upstairs on our 4th floor traveling exhibit hall. And it's got this thing in it. This thing right here, this big yellow ball, this thing's called a damper. And what it does is a big ball, and it's held with a bunch of springs. And whenever there's an earthquake or there's lots of wind, that ball shakes and it actually absorbs the shock waves and allows the actual tower itself to stand up straight. Oh, Amara and Nyla did say that triangles are the strongest shape. You're right. And you know what? I kind of cheated a little bit because I made this one skinnier. So that's probably why it fell over, because it was a little bit thinner. Now, I think that's really good though, Amara and Nyla. Now, I want to tell you guys about this damper, this specific damper, because this damper actually has a mascot, and you can see it over here. This little guy floating. His name is Damper Baby. And I thought it was cute that the damper has a mascot. Now, in your side of your kit, you have a sheet that looks a little bit like the one on the left. The one on this sheet of paper is a planning sheet for your engineering challenge that we gave you, the Straw Tower Engineering Challenge. Now, we've got an area to plan your sheet, plan your straw tower right here. We've also got where you can measure the height in inches right over here. Finally, you can, and these were basically the same height, but I wonder how height would change, which one fell over. That might be something you guys can experiment with at home. And then of course, we're going to be good engineers and good scientists, and we're going to record our notes for next time. Okay, friends, we've got one more activity that we're going to do, and this one is all about skateboards. Inside of your kit, you probably saw that you have a tiny mini skateboard. It's small, but it's mighty, and we were so excited to give you guys them. What we're going to do today is we're going to experiment with how changing the angles of a ramp change how fast the ramp goes down, okay? So let's check it out first, and then we'll talk a little bit more about skateboard ramps. So inside of your kit, like I said, you have your skateboard, but we didn't give you anything for the ramp, right? Sort of. We're actually asking that you guys use your box to be the ramp. So on your box, either on this side or on this side, you'll see that there's a black mark. And we're not going to do it right now because it will take a lot of time, and I have some really cool stuff I want to show you guys. But later, once you take your box home or you have a little bit more time, you guys can actually use your box by cutting this line and ripping the tape off to create one long skateboard ramp. And you can find things around your house to prop your skateboard ramp up on. Now, like I said, I wanted to make something special for you guys, so I have sort of a mini skateboard ramp to show you. I found some things from around the Science Center that I was going to park my skateboard ramp on. So I've got another cardboard box we're going to use. And then I've got, there's my cardboard box. And then I have a shorter version of the ramp that you guys have. So I'm going to get my camera all set up here, and we can see. Ooh, okay. Let's see if we can get it a little bit closer. I want you guys to be able to see the end really well. Okay, and actually, let me see if I can zoom out just a bit, see what happens. Oh, yeah, perfect. Okay, so this is kind of our test. We're going to see how long it takes this skateboard to go down this ramp. Okay, I know there's a little bit delay on the video, so I'm going to do it myself. I'm going to start counting in Mississippi, so I'm going to count seconds. So 1 Mississippi, 2 Mississippi, basically 1.5 seconds all the way down the ramp. Let's do it again, just for good sciences. Let's see, 1, 2, 3, 1 Mississippi, 2 Mississippi, almost 2 seconds. Not too bad. Now, if I wanted my skateboard to go faster, I could do a couple of things. I could reduce the friction here on the board, but I thought we could do something a little bit different. Actually, you know, I just reduced the friction because I found out that there was a seam, so I'm going to try it without the seam this time. Let's see. 1 Mississippi, 2 Mississippi, basically the same. So we reduce the friction, which is a force that happens when two things rub together. But I'm also going to use something else. I also found this here at the Michigan Science Center, this plastic bin, and I'm going to use that to prop it up. Now, you guys have a guess in your head. What do you think is going to happen now that the ramp is at a steeper angle? Let's see. What do you think is going to happen when the ramp is at a steeper angle? I propped a little bit more. And actually, while you guys are guessing what's going to happen to the skateboard if I prop it up on a steeper angle, I'm going to show you something really cool. Inside of your kit, we also provided one of these. This is a special math tool called a protractor. And this protractor helps us measure angles. So the way that we use it is you put it flat on the table. Yep, basically flat on the table to where the ramp meets the table. And then you measure to see what this line reads. What does it say right there? And it's kind of hard to see on camera because it's a clear protractor. But I will tell you, I did measure it earlier and it's about 140 degrees. So that's what protractors do. Protractors help us measure angles and they measure them in degrees. So this starts at 0 degrees and then straight up and down. That's a 90-degree angle, straight up and down. And then straight across would be a 180-degree angle. And if this is hard to understand, then I totally understand. Just read your protractor and you'll be able to see how these numbers work. We do have a guess in the chat. It looks like the taller ramp will make the skateboard go faster. So we had about, let's see, 2 seconds last time. Let's count this time. That's a great guess, Nyla and Amar. Yep, taller the ramp will make it go faster. Okay, let's see. 3, 2, 1. 1 Mississippi. That's it. It was just 1 Mississippi. Let's do it one more time. 1 Mississippi. That was it. Wow. Okay. So the taller the ramp did make it go a little bit faster. That is pretty cool. That was a great guess. You guys were totally right. Okay. And I've got a cool picture to show you guys to talk about skateboard ramps. Now, in real life, when we see skateboard ramps, they're not straight up and down like this one. Instead, in fact, we see a skateboard ramp that's curved, and calculating the angle of this curved skateboard ramp would be a little bit more difficult, but it's something that scientists could absolutely do. And as we know, the steeper the angle, the faster the skateboard would go. So this guy on this skateboard, he doesn't think he might be doing math, but he's probably doing a little bit of math in his head to figure out how fast he needs to go to get to where he's going based on that ramp. And of course, on the right, I have a picture of this dog walking up the ramp because I thought it was funny that he was walking straight up a ramp. This is more like the one that we made, right? The straight up and down one. Okay, now that was the end of our activity portion of the presentation. But real quick, I wanted to mention that inside of your box, along with the activity sheets and the binary code, you'll also see some featured scientists. And these were scientists that we here at the Michigan Science Center, we hold them very dear. Some of them are actually good friends of ours. They're Simonista role models. For binary code, you'll be able to read about Brittany Epps. And for straw towers, you'll read about Zaha Hadid, who was a very famous architect. She does some very cool stuff. You'll be able to read more about her. And finally, for skateboarding, we talked about the skateboarding physicist, Dr. Tay. Now, we're so happy you guys have joined us here for our show. It's quite a bit to fit into such a short show, but we're super excited you guys hung out with us today. On the screen in front of you, you will see a QR code, and that QR code leads you to a survey, and that survey is super important. Have your parents, have your friends, have your teachers, your librarians fill it out, because the more surveys we get for this is the more, let's see, it means that we can do more kits. We can actually bring you guys more MiSci in a Box kits if we get more surveys. So please fill that survey out. Tell us what you liked about the show. Tell us what you didn't like. Tell us what was fun. And actually, what we really want to hear about is what you want to see more of. What are other themes you guys would like to see in a kit? What are some activities or even some scientists that you guys would like to see in the kits? We are super open to suggestions. Okay, so that's the end of my show. We will see you next time. We have another box coming soon, and I look forward to seeing you guys again. This is sponsored by the Community Foundation of Southeast Michigan. Okay, we will see you later. Bye.